you're asking yourselves, why is he going to teach us all of these crazy math equations when we don't need any math for Lab 1? Well, that brings us to Lab 2. And I wanted to introduce you guys to some pretty cool stuff, and I also want to show you how to use a spreadsheet. First, let me introduce you to the math that we're doing so that you understand kind of where things come from. And yes, I do want you to calculate out everything because, you know, this stuff is really important for you to understand where it comes from, why you got it, all of that kind of stuff. Okay? All right. The first thing I made you guys do inside of class was actually I taught you guys about the Pythagorean theorem. The Pythagorean theorem has to do with right triangles. Here's a triangle because it has how many sides? You were going to say 4. Were you seriously going to say 4? Come on, we learned this back in 3rd grade.
3.
It has 3 sides. On one of those angles, and these are the angles in between here, on one of these angles I'm actually going to put a square. And that square indicates, by the way, Eric is hanging out with me today. And that little square in that corner indicates that it's a right angle. It's coming at a perpendicular, intersection. Does that make sense to you? Is anyone freaking out about the word perpendicular? Have you heard it before?
Mm-hmm.
All right, okay. No one's worried about that. All right. This right here is called the hypotenuse. And this here is just a side. And here's another side. We even call these legs sometimes. I don't know why they're called legs, because triangles aren't alive. They don't have legs, but those are the legs of the triangle, apparently. We sometimes call this side A and side B. And if I take a measurement of side A and side B, I can relate it to the hypotenuse using this very clever equation made by Pythagoras, a Greek mathematician and philosopher, that says a squared plus b squared equals to c squared. You know what? Let me see if I can find a really cool video on Pythagorean, on a proof for that. That way you know that I'm not pulling any of this stuff out of the top of my head. Let's look up Pythagorean proof water. There we go. All right, here we go. I thought this was a cool video. All right. Just a real quick heads up as to what this video is, and I'll share with you guys the link. Let me pause the video. But here's what you're going to see. You're going to see a triangle like this. Which is that triangle right there. And you're going to see kind of like a stuff over here, and there's like blue stuff over here, and the stuff over here is water, okay? And this is a right triangle. And if I take A over here and I make a box out of it, what is A squared measuring? It's actually measuring, how do you find the area of this square? That would be a squared, right? You would multiply one side times the other side to find the area of a square, right? And if this were b, then the area would be b squared. Good. And what I'm saying is the area over here plus the area over here would fill up a square that has an area of c squared. That's what I'm saying. Okay? So if I turn this triangle, if I turn this little toy upside down, then all of the water from here and all of the water from here should perfectly fill up all of the water in the big one. And if that's true, then would you folks be able to accept my equation a squared plus b squared equals c squared without me having to go through some rigorous mathematical proof for it? Which I would gladly do if I had the time, or if you guys were in my Algebra 1 class, but not so much if you guys are in my science class. All right. I'm going to play the video, but before I play the video, you guys, it will probably be glitchy for you. So with that in mind, I'm going to just hyperlink the video to you guys. And that way you guys can check it out. It's 44 seconds long, so it's not that long. It won't kill us to watch it. Give me the link. Let me give you the link. Give me a second. Let's see. Control V. All right. Here's the link. I'm spamming it to you right now. Check it out. And then, for Eric's sake, I'll sit here and watch this with you. I think that's so cool. Oh, snap. And then she turns it back. This is what nerds build in their free time. I love it. I love it. Come on, that's a little cool, right? And of course I like the word spam. My son always tells me when I'm playing Super Smash Brothers, you're such a spammer. It's because I use who's the boxer guy? Little Mac. I use Little Mac and I use the same moves, same combination of moves. I basically punch you up into the air and then I do like an uppercut special. And then, yeah, I spam way too much. And then I'll be like, well, I love spam. I grew up on spam. So suck on that, buddy. All right, anyway. That was a cool video. And it proved to you guys that a squared plus b squared is equal to c squared. Is that fair enough for you guys? Are you guys happy with that equation? Okay. So a squared plus b squared equals c squared, and no one's really complaining to me about it because we've seen a video that was pretty interesting, and it was, it showed us what we have to do. So for example, if a equals 3 and b equals 4, what is c equal to? C equals what? Then I just plug it into here. So we have 3 squared, which is 9, plus 4 squared, which is 16, equals to c squared, right? I skipped a step. Maybe I should write 3 squared plus 4 squared equals c squared. And 3 squared is 9, and 4 squared is 16, so we're good, right? 9 plus 16 is 25. And then I asked this question, and a 6th grader answered me last time. What times itself gives you 25? Is there a number that will give you 25? And the answer is 5, exactly. So C is equal to 5. Are we cool with that? We could also figure that out by taking the square root of both sides, because the opposite of a square is a square root. And then if you type into the calculator the square root of 25, you end up getting 5. Are we cool? All right. Now, I think I gave you a different one. I said, okay, well, what about if A equals to 5 and B is equal to 12? What is C equal to? C equals what? All right, so we plug it into our thing. Let's see. My equation is a squared plus b squared equals c squared. And so I have a equals 5 squared plus 12 squared equals c squared. So this would be 25 plus 12 squared is 12 times 12, which is 144, equals c squared. Let's see. 25 plus 144. Oh, I'm sorry. I'll slow down. 25 plus 144 is, let's see, there's a 9 and then a 6 and a 1 equals c squared. And the square root of 169 parentheses is equal to 13. 13. So C is equal to 13. No, I'm not yawning. You wanted me to slow down. Fair enough? All right. But I'll be honest with you, as we've seen, I happen to choose numbers that are very nice, that came out very nicely. Not all numbers come out very nicely. We could choose, like, for example, let's say, I don't know, A equals 7 and B is equal to, I don't know, 9. What is C equal to? And I don't know if this will come out nicely. I really don't. Let's try it. It's saying that 7 squared plus 9 squared equals to C squared. 7 squared is 49. 9 squared is 81. Let's see. This would be 130. I don't think that comes out nicely. I don't think that you can figure out a number that multiplies to itself to get 130 very nicely. And Faustine was saying, I'm going too quickly, and to be honest with you, feel free to use a calculator. In fact, when I'm showing you how to use a spreadsheet, I'm basically showing you how to build a calculator. So that's what we're going to do. Anyway, if you use the calculator and type in you type in 130, you end up getting, as Jonathan said, 11.401754251, which really you can just write down 11.4. We cool? And the reason, what I mean by nicely, Isabella, is this number was a solid 13. The previous number was a solid 5. But this one was 11.40752137896432. I don't know. Yeah. Anyway, it was just a long, crazy number that I wouldn't have been able to guess right off the top of my head. Fair enough? So, use a calculator, and that's what you get. Now, what does this have to do with our bridge? That's really the question. Actually, here's my question. Any other questions on how to figure out what C is if I gave you the Pythagorean theorem? Anyone confused about that process? No? No? Okay. Can I move on? Yes, good. What does this have to do with building our bridge? Well, if we come back here and say we want to figure out the length of M01, because I had you use a ruler to measure it, right? That's what I had you guys do when you guys drew it on a piece of paper. You used a ruler and divided that number by 0.62. Okay? But that's not the most accurate way of building a bridge. What you really want to do is get a super accurate answer. So, my question is, we're focusing on M01. My question is, do you see a triangle? And most people say, no, I don't. And then I say, well, what if I draw in some lines?
Yeah.
What if I draw on that line? And I draw on that line. Now do you see a triangle? And most people would say, yes, I see this triangle right here. Are we cool with that? All right. Now, based on these coordinates, what is this length over here? It's the vertical one. How high is it from here to here? Throw out the number, please. Chelsea says 10. Quinn says 15. All right, round one, fight. Who's right? Is it 10 or 15? All right, people are laughing, but I mean, Chelsea, obviously I don't want you to fight Quinn, but I'm just saying. Quinn is right. Chelsea says, ooh. Wait. Chelsea, wait. Chelsea, you're the one fighting against Quinn. Why are you supporting Quinn now? Which is even worse because actually Quinn is wrong and you were right.
Oh.
Oh, snap. This height is 10. The reason being is because, look, over here you started at 0, 0. The 0 for the first 0 is the x, the 0 for the second 0 is the y. Over here you ended at 15, 10, which means the y value is 10. The x value is 15. But I asked you, what is the difference of height? And you told me, well, the correct answer is 10. It's because that's the y value that you ended at. Of course, you have to take into account where you started it at. But in this case, you started at 0. So how many times did you have to press the up arrow, really? That's my question. Is 10 times to get from n0 to n1. Does that make sense to you?
Mm-hmm.
All right. And then, what is this length right here? Come on, Quinn, you got this one. It's 15. Very good. Because you went from 0 to 15. And so, we want to really figure out what this length is. So, oh, by the way, I'm just curious to know. How did you get 10?
Yellow.
What you did to get 10, and I know that this is kind of trivial to write down, but what you did to get 10 was you got 10 minus 0 is equal to 10. And over here you did 15 minus 0 is equal to 15. Are we cool with that? I just took this height right here and I subtracted off this height right here. And then for the 15, I took this length right here and I subtracted off that length right there. That's what gave me my numbers. And then so I would plug that into the quadratic equation. So apparently you're asking me to find a hypotenuse of a triangle that has one side 10 and one side 15. And you want to figure out what C is. And you plug it into your machine and see if it works. A squared plus B squared equals C squared. And you have A is 10 squared plus B is 15 squared equals C squared. And I don't know the answer, and use a calculator, and you guys figure it out. Because you guys told me that you guys have no problem with figuring out what C is at this point. Are we cool? All right. Let me show you one more thing, and then I'm going to say, and look how amazing that is. And then I want to move on to teaching you guys how to use a spreadsheet, because that's a really important part of this recording. I want to figure out the length over here. That's pretty easy. Actually, I guess I'll show you two more things. Yes, I know we have 20 minutes, and I'll do my best to go as fast as I can. I want to figure out the length over here. That's pretty straightforward. That is simply, I don't need to figure out a triangle at all. I'm sorry. This is 15, 10. And this is 25, 10. I apologize for my horrible handwriting. All right. I don't need to use a triangle at all. I simply need to do, what is my y? How high up am I going when I go from this point to this point right here, from N1 to N2? Oh, Jonathan's already got the answer. He's saying no, you're not actually going up anything. It stays the same. So you don't need to worry about that. But as far as going across, that's 25 minus 15, which is equal to 10. So the length from here to here is 10. Is that what you're saying, Jonathan? Okay, good. All right. So for completely vertical lines and completely horizontal lines, those are very easy to figure out. It's the diagonal lines that we're worried about. Let me do this one. Last one really quick. I just want to know. I see another triangle. It looks kind of like that because I want to figure out what the length of M23 is. In order to get how tall this side is, that would be this coordinate system is 35, 5. And you said 5. Yes, absolutely. How did you get 5?
I guess 5 because it's half.
Well, it's
So
because
it's
over
10.
here, you're starting at 10, okay? And you're going down, we're talking about the y coordinate first. This is Eric, by the way. He's hanging out with me. We're talking about the y-coordinate, and you're starting here at 10, and you're going down to where? And you're going down to 5. So if you start at 10 and you go down to 5, how far did you have to go down? You had to go down 5. Does that make sense? So I got 5 from 10 minus 5 is equal to 5. Are we cool with that? All right. Now, how far across did I go? I started here at 25, and I end here at 35. See my x values? So I went across 10. I got that from 35 minus 25. Ugh, it's horrible. 35 minus 25 equals 10. Are we cool with that? And then you would plug that into your quadratic, or not quadratic, but your Pythagorean theorem, and then done. Bada bing, bada boom. Let me show you guys something really cool. I already showed you guys Cartesian coordinate system, Pythagorean theorem, and I even showed you this without you even knowing it.
Oh, wow.
Oh, wow. Here, I'll show it to you one more time. You ready? What we wanted to do is we wanted to figure out the distance from here to here, the length of a line connecting those two, right? And so let's play that same game on this graph over here. How tall is my triangle? It's 4 minus 1, which is 3. We cool with that? How far across is my triangle? By the way, I should just write 4 minus 1 equals 3. That's what I should write. My triangle is 5 across, which came from 7 minus 2, which is 5. Right? Because I end here at 7, but I started at 2, so I would have had to press the right arrow 5 times to get there. Does that make sense to you? Is everyone cool with that? I mean, I'm just making sure that you all understand.
Yes.
Okay.
Not really.
Check this out. Wait, who's not really understand?
That's like a ghost.
Yeah, I know. Somebody's got their little voice thing on. I want to make sure you understand this. I want to be able to do the spreadsheet with you, and I think it's really cool. But you have to understand this math first.
I just got here like 11.
Okay. Let's see. Type in your answer. Don't do the audio. Sorry, I'm gonna turn your mic off. All right. So, what I'm saying is, to get the height, you would take this second y value and subtract off the first y value. Does that make sense to you? To get how high you had to go, you took the second y value, the 4, and you subtracted off the first y value, and you got the number 3, right? Hey, guess what? That's where the y2 minus y1 comes from. Huh? Now, to get this 5 over here, you took the second x value, the 7, and you subtracted off the first x value, which was the 2. 7 minus 2 gave me the 5. Does that make sense to you?
Yes.
And look, that's where the x2 minus x1 came from. And then what are you going to do with the numbers? You're going to take that 3, you're going to square it. You're going to add it to the 5 squared. And that will give you your c squared. Right? And in fact, in order to get c itself, you would square root this answer, whatever you got here. Well, that's where those squares come in. And that's where that giant square root comes in as well. You took your y2 minus y1, you square it. You took your x2 minus x1, you square that answer. Then you take the square root of the whole thing. I'll be honest with you, I just want you to know that this equation exists. I don't want you to use this equation today. I want you to actually do it this way that I showed you. Because I think this is way easier for you to understand. You get the separate legs of the triangle, you plug it into the Pythagorean theorem, bada bing, bada boom, use a calculator, and you're done. Don't use this crazy formula. Just use that. Because it's not crazy magic that we're doing here. We cool? All right. Now, how can I make my life even easier? Well, let's learn how to use a spreadsheet. So here's what I want you to do. We're going to use Google Spreadsheet to make a spreadsheet for some of our calculations. I want you to make a copy of this file. All right, so click on that. Go to File. I'm just going to follow the directions. Yes, a lot of those unread messages I already have taken into account from. Stop hounding me about my unread messages, please. Actually, I don't know. Am I snippy today? I hope I'm not snippy. I actually really enjoy hanging out with you guys. All right. So I opened up the file. I'm going to press File, Make a Copy. And it asks me for this thing. I'm going to put my last name. And I'm not going to actually type in the word last name. I'm going to put Dalday _ first name, which would be Mr. And I'm going to just leave the rest. Bridge Design, HSSO 2016. Cool.
So that's an assignment?
No, we got to finish this off. So I need you to type in all of the nodes. For example, our node, which was N0, was at, I think the coordinates, if we go back to our, N0, the coordinates was 0, 0. And our node 1 was at, I think it was 1510. 1510. And our node 2 was at, was it 2510? And our node 3 and 3 was at 35.5. Cool? All I did was I'm using the spread. I'm using the thing that we drew over here, and on yours it's going to be much nicer on graph paper. But I'm using the thing that we drew to figure out where the different nodes are. I know. I only have 10 minutes left, and I'll tell you what. I'm going to finish off this recording because I think I need to finish it. You guys can leave if you guys want after the 10 minutes. I apologize if I go over. What even is a node? What is a node? Okay. A node is like the connecting points on your bridge. They're the points where your
Connecting dots.
they're the connecting dots. They're the points where the two pieces of your bridge meet up. Does that make sense? All right. A lot of times you'll hear it as the part that doesn't move, but I think the better one to type or would be, to just call it like that. All right, let's see. Open up a spreadsheet and call the first cell A1 node. Okay, so I already did that for you. We're going to make a new tab on my spreadsheet by adding the plus sign to it. So here's the plus sign on the bottom. I have sheet 1 already. I want to make a second sheet. So I'm going to add sheet, and there's another sheet. Got it? I think I'm going to call this one we'll call nodes. And I think this will be called mem1. Which talks about, these are the members of each of my, these are the members of my first bridge I'm designing. We cool? All right. Now, what I'm going to do is I'm going to skip the first row and column. I'm going to reserve this for something special. I'm going to label B2, so this is cell B2. I'm going to call this member. I'm going to call this one L node. I'm just following the directions that they gave me here. Node. L node. I'm going to delete this. I'm going to call this one X, Y. I'm going to call this one R node. I'm going to call this X, Y. And I'm going to call this shrunk, measured length. I'll call this one measured length. I'll call this calculated length. this will be model length, millimeters, and so on and so forth. Got it? Oh, let's just finish it. Angle, and what else do they want me to do? That is it. All right. So, there's a lot of little things that I have. Got it? Now, going through the directions. In B3, put the name of one of your members. So, for example, member, I'm going to call it M01. Because if you look back at my drawing, member 01 was over here. Okay? And what are the names of the nodes that it's connecting? Well, it was connecting N0 and N1. And what were the coordinates of that? Well, this guy was at 0, 0, and this guy was at 15, 10. Are we cool? Does anyone have any questions about what I'm doing here? I mean, I don't feel like it's magic. I'm just following the directions. All right. I called this one L node because it's the left node. It's the node over here that was on the left, N0. And I called the other one R node because it was the right node. And I gave the coordinates, the 0, 0 and the 15, 10, to the spreadsheet. And there you go. All right, let's see. What I want you to do, what I want to show you is actually this calculation right here. This calculated length, because I think this is really cool. Right here. All right, here's what we're going to do. We're going to, I'm going to skip some of these steps because I want to show you something really cool. And I don't have a whole lot of time because I know you guys are really hungry. All right, check this out. I'm going to type in this into my formula. I'm going to start it off with an equals sign. All right? And then I'm going to type in the word SQRT and put parentheses around that. SQRT stands for what?
Square root.
The square root. Very good. So I want to tell it, hey, I would like for you to take the square root of something for me. And it's going to say, well, what do you want to take the square root of? And I'm going to say, well, I'm going to put a parentheses and another parentheses. I'm going to go in the middle of that. I want you to do this cell minus this cell. So this would be the y values of the second coordinate minus the y value of the first coordinate. See? The y value of the right node minus the y value of the left node. Are we cool with that? And then I want you to take that number and I want you to square it. So I'm going to put a caret with a 2. Got it? Nothing magical about that. And then what I want you to do is I want you to add another thing for me. I would like you to take the x value of the second coordinate, x2, minus the x value of the first coordinate, which would be here. Wait, I messed up. I wanted you to do it was this one. So let me just delete this. I wanted you to do this one minus the x value of the first one. So that would be this one. And I want to take that number and I want you to square it. If you are totally confused with what I did, just type in exactly what you see here. Okay? And it will give you the same answer. I want you to press enter. And look, it tells you 18 point blah, 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 blah. But guess what? The computer did the Pythagorean theorem for us. It already did our calculation. Because if we were to come back here and we were to finish off this thing, let's see, coming back here. This is a 10 squared, which is 100, plus 15 squared. Does anyone know what 15 squared is? 15 squared, which is 2, I bet you it's 225. Yep. 225 is equal to c squared. So 325 is equal to c squared. So c is equal to the square root of 325. And if we take the square root of 325, square root of 325, what do we get? 18.0277. But guess what? It's the same number there. So instead of having to calculate it out every single piece, the computer will do it for us. And then let's say, all right, let's do another member. We were going, so let's see. Another member in our thing was M2 or 1, 2. And that was going from node 2 or node 1 to node 2. And node 1 was at coordinates 15, 10. And node 2 was at coordinates 25, 10. Got it? Now, instead of having to retype that equation, all you need to do is basically drag that equation down. To do that, you click on the equation you want to copy, and you go to the right-hand side, and there's a little plus sign, crosshairs that will appear. I don't know if you guys can see that on your computer, but I have it on mine. You just click, grab it, drag it down, and it will calculate out that length. And we already told you what that length was. We already said that was 10, right? You remember this thing over here? That was 10. In fact, I can figure out this last one over here. Let's see, 25, 10, 35, 5. All right, let me go back to my spreadsheet. So member 2, 3 was going from node 2 to node 3. The coordinates of node 2 was 25, 10. The coordinates of node 3 was 35, 5. And I'm going to click on this equation over here. I'm going to go to the bottom right-hand side of it. My pointer will change into a little plus crosshairs. You can see that, Eric, you can see that on this computer, but it doesn't appear on this thing. I'm going to drag it down. And my answer is 11.1803389. The computer is doing all of the work for me. That's pretty cool. Now I don't have to do the Pythagorean theorem. All right, so now you guys are going to say, wait a second, Mr. Daldy, why don't you just give me a copy of this? Why do I have to make my own equation all over from scratch? And I'll say this, well, because a part of teaching you science is teaching you how to use cool programs like this. What are we going to do on Wednesday now that you ask? Since you guys are like, wow, man, I don't want to stay. I got to go. I'm so hungry. Well, all right, here, let me tell you what we're going to do on Wednesday. On Wednesday, we're going to take this bridge that we designed, and we're going to build it into a engineering program, and we're going to replicate, and we're going to do some engineering analysis on it. Also on Wednesday for class, for lecture, this isn't going to be a live class that you attend. This is going to be a virtual class. But also on Wednesday, we're going to build our bridges in 3D using all of this information that we gathered here. And next week, Wednesday, yes, that's what we're going to do. We're going to build it in 3D. Your 3D bridges is going to be due to me by Monday. The best ones I'm going to take on Monday that students turned in on Monday. I'm going to take those. I'm actually going to print those out for you. The best ones. The best ones being the ones that have the most research done on it. And I will print it up in 3D. And yes, Off-Islanders, you guys can participate in this because you guys can just send me your files. It's that easy. And then next week, Wednesday, when you come in for lab, we are going to have a bridge competition where you take your bridges that you built and we will break them and see who does the best. Got it? So the reason why I needed to go through the crazy complicated math equations with you, which wasn't really that bad when you think about it, it was just the Pythagorean theorem. That distance formula was just the Pythagorean theorem in disguise, right? But the reason why I wanted to do that is because if I were to tell you, hey, type this up in your equation right here. I want you to type in square root of h5 minus e5 squared plus g5 minus d5 squared. You would be like, what the heck are you talking about? Where did you get that craziness from? Right? But now you look at it and just be like, oh, that's just the distance formula. You know what I mean? All that is this distance formula that I told you at the beginning of class I would teach you. And all this distance formula is the Pythagorean theorem that you know how to do, and it's not even that hard. Math, complicated math, made understandable. Brought to you by Mr. Dalday. All right, kids, I'm done lecturing. I had fun with you. Yes, you have a wonderful day. I hope these instructions were clear. I skipped a few things in Lab 4 and Lab 2. You guys can go. Let me just kind of take a look at Lab 2 to make sure that there's some pieces that like I'll go through and you don't understand. Hopefully you understand. Let's see. So you guys can leave. Please feel free to leave. I'm just gonna record some more of this stuff. What I wanted you to do is I wanted you to take this thing that you measured out, and I wanted you to measure out each of the members. So you take a measurement and you put it here, okay? And that's the actual measurement on the piece of paper that you printed out from Lab 1. And that would be for instruction number 11. So for instruction number 12 was basically you just go through your entire bridge and measure out the lengths of each of these things. And then what I want you to do is you can use the spreadsheet because in the when you guys actually drew it up on paper, you guys divided everything by 0.62. Well, you can have the computer do it for you. So you can just say equals. I want you to what do I want you to put inside of this cell? And you're telling the computer, and you say, all right, computer, I want you to take this cell, and I want you to take whatever's in the previous one, whatever number you put in, and divide that by 0.62. And it says 0 because there's nothing here, so nothing divided by 0.62 is 0. We'll copy and paste that thing down all the way to the bottom. And we can put in numbers here like 4, actually maybe like 14. And then like 7. And then like, I don't know, 13. Or no, not 13, but like 9. No, 7. All right. So we can do that. And then what you want to do for question number 14 is you want to, wait. So for question number 14, what you do is you're going to drag that formula down. That's what I did right here. And then what I want to do is I want to sum these things. So in order to, for question 15, I want to click here. And I want to say equals the sum. And what the sum means is I just want you to add all of this stuff for me. What do I want you to add? I want you to go add all of these things for me and go all the way down to 40. Then you close that parentheses, press enter. And what it does for you is it adds up all of the numbers here. And you can actually have it do the same thing across like that. So 11 plus 6 plus 7 is 24. This number plus that number plus that number is 38. This number plus that number plus that number is 39. Anyway, I think that I wrote out the instructions pretty clearly. The only crazy one is this arctangent thing. But just type in those things straight in as you see it, and you'll be all right. All right. With that, I'm going to stop the recording. My students are thoroughly confused at this point. All I did was I actually just kind of tried to finish off the instructions for the second lab, but you guys were allowed to leave back at 11:45 if you wanted to. I just wanted to take the last 5-10 minutes to finish off the instructions so that when you guys go through this lab, you guys won't be thoroughly perplexed. Cool? All right. Okay, bye.